Hello everyone, and thank you for joining us today for Monitor Privileged Users with SDS's CryptoAuditor. Remove the veil from your trust circle. We're excited about our SSH key product solution, CryptoAuditor, that we will be presenting today. I'd like to introduce you to your speakers. I'm Yvonne Wheaton. I represent the marketing department at Software Diversified Services. I have over 30 years in the IT business, both in system shops and an enterprise vendor environment. Craig Riddell is a senior technical service engineer at SSH. His background includes deep expertise in enterprise IT, Unix systems, and secure shell or SSH. He is familiar with SOX, HIPAA, PCI DSS requirements. Craig is a CryptoAuditor expert. I'd like to take this time to mention that SSH Communications has just been awarded the gold winner of a Golden Bridge Award in Encryption Key Management Innovations for their Universal Key Manager product. Golden Bridge Awards are an annual industry and peer recognition program honoring best companies of all types and sizes from all over the world. Colin Vandeross, a senior systems engineer here at SDS, has over 25 years' experience as a customer at a large bank. He's been at SDS for over 8 years now, focused on network software solutions and security solutions. Deb Hodson is also on the line with us today. Deb's the sales manager at SDS and has 30-plus years in the IT business, having been at IBM, HP, Candle, and now SDS, all in sales and consulting roles. Deb and Colin will be joining us for our Q&A session. Here's our agenda for today. I will cover the SSH key information and management. What does it mean to let someone in your trust circle, audit compliance, as well as an introduction to the NIST IR 7966 document. Craig will provide an introduction to CryptoAuditor and how it can be used to track key traffic along with a demo so you can see the CryptoAuditor solution in action. At the end of the presentation, we'll close with a Q&A session. SDS, or Software Diversified Services, has been providing mainframe solutions to the market for over 34 years. Our headquarters are located in Minneapolis, Minnesota. SDS is a leading provider of enterprise infrastructure software for multiple platforms, including ZOS, MVS, VSE, and VM mainframe systems and distributed products. We're proud of our world-class support with a 30-plus year history of delivering award-winning support and customer-centric IT infrastructure solutions for more than 1,000 clients worldwide. Our flagship products are dedicated to network management, security solutions, and performance solutions. SDS has over 20 enterprise-wide products. Our development staff is continually providing rich, robust updates and enhancements to our products. The SSH product solution, SSH Tectia, has been a part of our array of SDS enterprise product offerings. We are pleased to announce that we have added CryptoAuditor along with Universal Key Manager, which will be the focus of our webcast in October, to round out our SSH product line offerings. You'll find any handouts for this presentation on your dashboard under the Handouts tab. You can access and download these at any time during the webcast. At the end of today's presentation, we'll be providing a Q&A session. So if you have any questions at any time during the webcast, please send them to us in the question box. If you have a question or you'd like more information, you can always send us an email to info@stsusa.com. Thank you again for joining us today. I hope you will find we cover some areas in SSH key management that you're interested in and security risks that you may have in your enterprise environment. Secure Shell is a cryptographic network protocol for operating network services securely over an unsecured network. It's a protocol for securely logging into a remote host and executing commands on that host. In 1995, Tatu Lanen, a researcher at Helsinki University of Technology, Finland, designed the first version of the protocol, now called SSH-1. He released his implementation as freeware in July of 1995, and the tool quickly gained in popularity. Toward the end of 1995, the SSH user base had grown to 20,000 users in 50 countries. It is estimated that as of 2000, there were 2 million users of SSH. In 2006, a revised version of the protocol, SSH2, was adopted as a standard. New features of SSH2 include the ability to run any number of shell sessions over a single SSH connection. With the popularity of SSH, systems that use SSH have accumulated a vast amount of keys, in some cases millions of potential unattended keys. These keys, initially created to support employees or processes to do everyday tasks and automation, have been left in place, creating security issues in many areas of their enterprise. When you think about a private key and a public key, think about the private key as your own house key, and think about the public key as the lock to your door and your environment. The control, when we talk about SSH keys, is on the locked side of the access or public side. The current version of SSH protocol is 2.0. The SSH protocol has a typical client-server architecture. There are many considerations to take into account when selecting authentication methods for SSH across an enterprise. There are many kinds of authentication methods, including server authentication, client authentication, password authentication, host-based authentication, and Kerberos authentication. In each of these, there is a creation and an acceptance of keys. In a password authentication process, first, user 1 initiates a logon to host B. Second, host A authenticates host B using the host B public key stored in user 1's known host file and establishes an encrypted connection with host B. Then user 1 is prompted for a username and password and potentially other requirements by host B. Lastly, the credentials are sent to host B over an encrypted connection. Host B authenticates user 1 by verifying that the credentials provided by user 1. I thought it might be interesting to share with you what a set of keys look like. This is what your basic key pair looks like. All the key file is just a bunch of letters and numbers mixed up and strung together. Keys grant access when key pairs match. There's no identity associated with it, so in reality what is hidden is the ability to go from host to host after transient trust is established. These keys create trust relationships. So, a private key and a public key pair can allow a user to connect to a remote system on a one-to-one relationship. It can support a one-to-many so that public key is now distributed across multiple servers. Or you can have the example of multiple administrators, each with the same private key, having access to a server that has the corresponding public key. Then you can have the many-to-many relationship. So you can see with the proliferation of keys, you can have some pretty complex kinds of trust relationships. In this representation, there are 582 servers, 8,100 trust relationships. So you can see the unknown authorizations in red show a public key without corresponding private key locations into that environment. Another example is a separation of duties. Here we identify the trust relationships that go in between development, production, and other areas, both from the perspective of one environment to the other, which is generally a violation of separation of duties, and also from unknown sources, which means someone out there with a private key that can get into both production and development. Red is our unknown source, green is production, and blue is development. So you can see there's quite a bit of unidentified transitive trust. In this real-world example of a financial institution that is a global 1,000 diversified company, they accumulated keys over a 10-year period of time with over 10,000 servers in their environment, with 1.5 million keys identified and an estimated 75 to 80% application type keys. 10%, or 150,000 of those keys, were unknown, also had root access. Nobody knew who could access what servers or what data. This financial institution was covered by SOX and PCI, so it had to adhere to strict standards. With no ability to monitor traffic on their network and unaccountable SSH keys, all of this resulted in a failed audit. So when we talk about compliance, we have to keep in mind SSH is also used for communications with other organizations, external systems, or independent users. A closely related issue is the trust relationship that these keys establish within and between systems, even between organizations. Some of these trust relationships may be undesirable or violate policies, such as leading from development and test into production systems, or crossing from a low-impact system to a high-impact system without requiring any additional authentication. Most organizations have no process for managing, removing, and changing access-granting SSH keys. This violates SOX, FISMA, PCI, and HIPAA, all of which require proper control of access to servers and proper termination of access. Unlike certificates, SSH user keys have no expiration date and are valid forever. This exposes organizations to a massive risk of misuse for the unused, unknown, unrotated, and depreciated user key-based access. There could be potentially millions of keys being deployed across an environment of which we don't have an inventory, and we don't really have a good visibility or oversight of the trust chain, and therefore we're in the dark in terms of who has generated the keys, who's using those keys, and why are they using those keys. Data exfiltration is also called data extrusion, or the unauthorized transfer of data from a computer. The accounts associated with keys often grant far more access than is actually needed, such as allowing execution of any command or transfer a file to any directory. Also, in many organizations, system administrators configure new keys without any approval or coordination, and may use them to circumvent auditing or privileged access and maintenance. Some large enterprises have hundreds of thousands or even millions of SSH user keys in their systems for automated access, which often provide many more entry points into servers than the interactive user accounts do. When we look at a well-known incident of an NSA breach and how he succeeded in stealing the documents and then exfiltrate the data, we see a situation where he was allowed to increase his level of authority unseen. He was not being tracked or managed, so he was able to jump from system to system as an insider to obtain all level of NSA documents. Because SSH is the primary secure access method used for administration and automated processes on mission-critical systems, its security is critical. The security of SSH-based automated access and even interactive access has been largely ignored to date. Many organizations don't even know how many SSH keys they have configured to grant access to their information systems or who has copies of those keys. NIST stands for National Institute of Standards and Technology. It is a part of the Department of Commerce. The Interagency Report 7966 came out for the security of automated access using Secure Shell. Secure Shell keys, in effect, are authenticators, just like your own user ID and password. These keys, just like your own user ID and password, need to be managed. There's a lifecycle management requirement, making sure that keys are decommissioned and updated regularly, and that the keys are kept secure and not lost or stolen and then used by an attacker. One of the things you'll find in the NIST IR 7966 document is a set of primary categories of vulnerabilities in the SSH-based interactive and automated access, with a particular focus on user keys used to grant access in public key authentication. It is followed by a set of SSH best practice mitigation. You can see one of the concerns is SSH is highly susceptible to enabling unauthorized access due to improperly configured access controls. Also, malware can be engineered to use the SSH keys, and there's a potential for human error. Under Section 5, Recommended Practices for Management, the NIST document states, effectively securing SSH access consists of defining clear policies and implementing management, operational and technical security control processes to address already deployed SSH systems, privileges, and user keys, and ensure that new SSH systems and user keys are properly deployed and tracked. We've provided a copy of the NIST IR 7966 in document form in the handouts area. In a controlled provisioning and lifecycle process, provisioning interactive or automated access requires these phases: request approval, provisioning, usage logging, review, reauthorization, and termination. Today we're going to talk about usage logging, logging usage to facilitate reauthorizations, forensic investigation, and audits. The Ponemon Institute did a 2016 Global Encryption Trends study. I'd like to point out two interesting facts that resulted from this study. The employee mistakes. According to 50% of respondents, employee error is the most significant threat to sensitive or confidential data. 30% chose system or process malfunction, and 28% chose hackers as their most significant threat. The fact that the top two findings on threats relate to mistakes or errors as opposed to targeted threats is notable. When compliance is the main driver, 61% of respondents see compliance with privacy and data security requirements as the main driver to extensive encryption use within the company. 50% of respondents see protecting enterprise intellectual property as the main driver. So what are the challenges enterprises face today? Most organizations, if not all, lack visibility of SSH user key-based trust regardless of whether that is an interactive or machine-to-machine connection. The ratio of what has been found out in the market space is that 10% of access keys are interactive or human-based access and 90% are machine-to-machine based access. A majority of organizations are not monitoring how those keys are being used, and this is really important because without that information of how frequently and from where the key-based access is occurring, we can't really determine whether the keys are still in use or obsolete, and we can't make decisions about rotation and renewals based on this, or to remediate non-compliance access because we simply don't know what is on our enterprise. SSH keys are ubiquitous. They are everywhere. They are used in network management. The internet, as we know, is largely used by SSH by logging into routers using SSH. Hardware in your data center is largely managed with SSH. You can log in and install an operating system remotely. That also extends out into the cloud. It is a primary means to access our cloud as well as send data to our cloud. On the application layer for file transfers, for application integration, and so on. Managing remotely is enabling data centers to be in a different location than the administrators, enabling outsourcing administrators to be in a faraway location. Craig Rydell is going to show you the solution to these issues. He will also provide a very interesting and informative demo to show you details on how CryptoAuditor can expose your potential security and compliance risks. Thank you again for joining us today. Craig?
Hello, everyone, and welcome to CryptoAuditor. Quick product overview, and then we'll follow up with a demo. My name is Craig Rydell. I'm a senior pre-sales engineer with SSH. I specialize in CryptoAuditor. We go over a little bit about product function, features, a few use cases, and where we sit in the marketplace. So in the cloud privilege access management space, we have the ability to control third-party privileged access. We can integrate with advanced firewalls on layer 7 or through a port or policy-based routing, depending on what the customer has in their environment. CryptoAuditor gives us the ability to monitor the traffic, control what users can do once they're authenticated to the destination, and then also audit it by enabling access for your DLP, IDS, IPS into these encrypted sessions. CryptoAuditor for third-party privilege access management really is not only about controlling third-party contractors and things like that are coming into your environment, but also being able to control what your admins are doing, having a nice audit trail for your privileged account sessions and things like that. So we'll start with a firewall use case. CryptoAuditor can integrate with advanced firewalls, as I said before, either through an application or port-based routing policies on layer 3. Quick and easy to deploy, no need to change any user experience at all. It's completely transparent, no need to install any agents. Fairly simple to configure the firewall rules. And really what we're looking for here is controlling access right at the firewall layer and going ahead and inspecting the traffic, one, to make sure that no malicious data is getting into the environment, and two, to make sure no sensitive data is leaving the environment, as well as having that full audit trail with the ability to record a full video replay and download those as text files that are digitally signed for forensics. So CryptoAuditor being able to kind of close the blind spot that encrypted access creates. So encryption is great. Vormetric released a report last year that said 70 to 82% of all traffic in enterprise environments is done through encrypted tunnels. And that is a little bit dangerous because now all of these solutions, your firewalls, your IDS, IPS, DLPs, SIMs, all of these types of things that you've put into your security are now blind to really what's going on. So you can see, there's an SSH tunnel established, for example, but not really what's flowing through that tunnel. So CryptoAuditor gives us the ability to monitor what's being brought into or taken out of the environment. Again, control what users can do once they are established into the environment. So, for example, we can explicitly deny tunneling or X11 or the ability to move data through SFTP or SCP, and then audit those. So pass it off to a SIM for predictive analytics, for example. CryptoAuditor really has two parts. There's the vault and the hounds. So the vault is really going to be your central policy management engine, and then the hounds will be distributed out through your infrastructure in one of three ways, either as a bastion, a router, or a bridge. And we'll go over that a little bit more in depth in the product demo. It's a network-based inline virtual appliance. It's completely transparent to the end user. There's no need to change any existing tools or install any sort of agents on any endpoints. We can not only record the sessions, but we can save these replays. They can be downloaded. It's a great tool to not only monitor and control what users are doing, but it's also been used in some customer environments for creating quick training because you have the ability to download just a whole session replay. We provide visibility into encrypted tunnels such as SSH, SFTP, SCP, Windows remote desktop, HTTP, HTTPS, and even some TCP. So, real high-level overview of CryptoAuditor from an architectural standpoint, just being able to kind of plug these in and then create a rule. And as you'll see when we go through the product demo, it's similar to configuring a firewall as we have that top-down rule perspective. And rules can be configured on a protocol by protocol basis. Here's just a couple of quick screenshots so we can see we're inspecting some privileged remote connections. You see there's some SSH, there's a session there at the top, and then just some command execution. So even if you're just running a single command through an SSH tunnel, we'll go ahead and audit and record all of that as well. So CryptoAuditor for third-party privileged access. This is one of our larger use cases, and really what this does is we find that most enterprise environments have some sort of contractors. This is kind of a bi-directional benefit. So we have some contracting companies who are customers of ours that will deploy the product so that they can basically give their customers peace of mind saying, we can show you a full audit trail of what every single one of our resources did on your system. And then also on the enterprise side, because then you can see that full audit trail. You can control what your third-party resources are doing, making sure that they're not gaining access to servers they shouldn't have access to, setting up time-based authentication credentials, and then also making sure that the day the project's over, all of their credentials can be revoked. Layer 3 deployments integrated with the firewall is something that we are starting to see a lot of traction on, especially in banking and other compliance-driven areas where anybody who's logging into a production system needs to be audited. So basically, we would deploy the CryptoAuditor at the firewall or at the VPN and just simply create a policy saying that all the traffic needs to go to a hound. The hound would then communicate with the vault, do all the integration checking. So this is where your multifactor, your authentication, your DLP, your SIM, all of that type of stuff would occur. And then CryptoAuditor will re-encrypt the traffic, pass it back to the firewall, and then send it out on its way. Multi-factor authentication is something that I think everybody's kind of starting to talk about. Generally, what we look at is multi-factor authentication has been done primarily at the border. And now we're starting to see a lot more multi-factor authentication vendors trying to establish and move beyond just the perimeter. So adding in different credentials to access a PCI environment, for example. From an ease of deployment standard, CryptoAuditor comes in and plays quite nicely because most MFA vendors require you to either install an agent or make a configuration change so that it knows to look for the multi-factor authentication. And it's a little bit of an overhead. So with CryptoAuditor, we'll go in and we'll create the integration on the CryptoAuditor side. It takes away the need to change those configuration files or to install those agents. And it's more of a light switch. So basically, we can just turn it on through a rule, and you'll see multi-factor authentication enabled out to that specific subsection of your environment or your whole environment. And we'll dive a little bit more into that in the product demo. Quick CryptoAuditor case study. We did deployment for an industrial automation system maintenance vendor. Large industrial corporation uses a lot of automation, lots of third-party access coming in because they have to have experts in specific fields. And they were accessing production systems with fairly limitless credentials. And we put CryptoAuditor in place to monitor the interactive, the non-interactive SSH sessions, the RDP sessions, and even some web-based application sessions. So the deployment time for this was relatively short. CryptoAuditor can be deployed and monitoring traffic in about 2 hours. And then we just kind of make some fine-tuning from there to make sure that people can only access what they should be able to access through host groups. And we can get into user mapping for kind of that privilege account management piece. So what did we do with them? We enabled multi-factor authentication. We limited who could access which servers, and of course audited those connections, recorded the full session. We integrated with an IDS and DLP to make sure that no malicious data was coming into the environment, and also prevented data exfiltration. We increased efficiency because a lot of vendors had their own portal that they would log in through to the customer's environment. Instead, we just deployed CryptoAuditor and then distributed hounds out to replace those vendor portals. That way we can make sure that there was no other way for them to access the environment, no backdoors or anything like that. And then make sure that they're not logging in for unnecessary reasons. So we worked a little bit with a change control process to be able to go ahead and leverage that to where they could create, basically access requests and then log in through CryptoAuditor. And through the time-based credentials, we made sure that they didn't stay on the systems for longer than they need to. So primarily when we go out and talk to customers, it's compliance driven. So what are you trying to accomplish from a compliance standpoint? And that's generally the third party access piece. Your risk management systems. CryptoAuditor can integrate with everything to give you visibility, the tools visibility that you're already paying for, like your IDS, your IPS, your DLP, some advanced pattern analytics through SIM integration, things like that. And then just operations efficiency. We have the ability to deploy this very, very cheap. It's a quick deployment, so not a lot of need for professional services, and no need to change any sort of existing user experience. So no need to go out and retrain your user community or anything like that. What I really want you to take away from this high-level overview is we have the ability to monitor and control third-party access, as well as integrate with firewalls so that it's really ease of deployment. The opportunity to enhance your security posture by integrating and giving visibility into these encrypted tunnels is pretty amazing. And then the compliance requirements. So your PCI, your HIPAA, your Monetary Authority of Singapore, we can really work quite well inside of these frameworks. And now I'll take you through a quick product demo.
This is the home screen for the CryptoAuditor product. Here you can see any open connection, any logged in users, and a quick glance at system status. If we go ahead and open up a SSH connection here, you'll notice that I'm going to log in with this SSH admin account. This is going to be an LDAP account, and when I authenticate, I'll actually be pushed out as the root level user. And during the authentication process, you can see that this has been picked up by CryptoAuditor. So we can see here there's a new SSH session, source and target IP, the port it's coming across, any data if it's been transferred, the rule that it's being monitored by, and we'll go into a little bit more detail on that. And then the target user right here is probably the most important part. So I logged in using my SSH admin credentials, but I was actually pushed out as root to the destination machine. And then if I go ahead and click on this session, I can watch this user session in real time, as well as have the ability to download this full session as a video, as a text file, with timestamps that are all digitally signed for forensics. So inside of this session, we can go ahead and click the live button and then go back into our PuTTY window here. In the demo environment, there's about maybe a 1 to 2 second lag versus in the production customer deployments, you'll see typically about a half a second or less. If we go ahead and look into this secret file, for example, we'll see here that this data is redacted. And what I mean by that is you see these X's on your screen here. This is done through a DLP integration. And then if I look at this top secret file, we can see here that it's just going to kick me out to a prompt as saying I don't have permission to view that data. This behavior is configurable, so you can have this automatically terminate session based on offending behavior, for example. DLP integration is fairly easy through CryptoAuditor. We can integrate with anything as long as it communicates over ICAP. And then if you had some sort of DLP alerting set up, then you could basically come in and watch this user session in real time. And then if they were doing something that violates your security policy, we can actually terminate this connection in real time as well. So you notice here, it's been disconnected with the reason test. Now we can go into this Trails and Logs tab, and this will show every connection that's ever gone through CryptoAuditor. So you see some SSH, some RDP, some SFTP sessions down here, some simple command executions. So we can go back and we can view these videos, download the sessions again, but one of the powerful things we can do here is actually search based on keywords. So if I search for that secret command, for example, I can actually come in here and see the video. So it earmarks it nice for me, and then if I click that, it'll play the session from that point forward and highlight the command on the screen. Now this is done in real time for SSH and SFTP and SCP sessions, and then as part of our post-process indexing, we can actually do this with RDP sessions as well through optical character recognition. The policy tab here is going to be the heart and soul of the CryptoAuditor product. So this SSH rule, if you remember, this is the rule that audited the connection that we established a second ago. It's just auditing traffic on port 22, but we can expand this to audit traffic on several ports, and then create a rule to deny all other SSH traffic, for example. We can add from stanzas in here if you're expecting connections only coming from a specific IP range, or even do VLAN tagging if we go ahead and deploy this in layer 2, and we'll cover that a little bit more in depth later. Your client to hound authentication is going to be a simple password relay. You can create a local user database inside of CryptoAuditor. Of course, integrate with your LDAP, your AD, your radius servers, and any multi-factor authentication vendors, and we'll go into that here in just a minute as well. And also X509 certificates. So this is going to be your common access cards, your PIV cards, things like that. And then mapped user credentials is what we use to be able to map out to that root user. And we'll show you the user mapping here in just a minute. Manual authorization, this is typically used for classified information. So you could enable this and it would actually hold the connection at CryptoAuditor. An email would be sent out to your admin team, for example, and they would have to log in and actually approve this connection before it got authenticated out to the endpoint. We are using DLP solution. You can see here we're using bits over ICAP, and then down here is where we can really get powerful and kind of control what users can do once they are authenticated out to the destination. And again, this is based on group membership. So we can, for example, deny the ability to move data around. So we could deny the SFTP and SCP channels, or for your non-interactive accounts, we can actually come in here and deny shell and execute permissions, as well as you can see here local tunneling, remote tunneling, and X11. We can do similar things through RDP. So for example, denying access to a clipboard or the ability to move data. Host grouping, this is going to be an ad hoc container. This could be anything from application-based servers to geographical location. As you can see here, I'm just monitoring this specific subnet, and this comes into play with our user mapping feature. Known host, simply the host key fingerprint. It's going to grab it on the first authentication through. If host key checking, strict host key checking is a security requirement, we can enable that. All that means from a CryptoAuditor standpoint is that you'll have to upload the host key before you're going to be able to authenticate to any destination servers. Certificate validation and certificate profiles. This is tying back into that X509 certificate. So we can see here I have a demo certificate for my CA. And then in the certificate profile, I'm going to be able to go ahead and specify that I'm going to map my certificate out to an LDAP account and which part of the certificate that we're going to go ahead and authenticate against. Users, user groups, and user mapping, all three of these play together. So this will be how we were able to authenticate as root without actually knowing the root password. So we have a LDAP group set up, and basically anybody in this group will be able to come in and leverage this user mapping. And this user mapping, we generated a random root password and deployed that out to the destination. We could also generate a key pair where the private key would be stored inside of the CryptoAuditor vault, and then the public key could be deployed out to the destination servers for these accounts. So you can see here anybody in this root user's LDAP group communicating over SSH to that admin1 host group will be pushed out as root without actually having to know the root credential. And all of this can be done with a script-based approach through our API. The admins tab, primarily here to show separation of duties. Again, we can create local user accounts or integrate with your LDAP or AD server. Some examples would be like your super users, so your crypto admins, any report admins, so people can come in and kind of create reports, things like that. Your API user community, and then your forensics team, so the people who can actually go in and see those full session replays, download those text files with timestamps and things like that. And lastly, the settings and system tabs will be something that you'll probably go through one time on initial configuration, and then unless something changes in your infrastructure, you probably won't go through this again. So your archiving, I have mine set to archive and purge every 6 months. We have some customers that archive and purge every 3 days. We have some that store data for 7 years. This is completely dependent on your security posture and what you need to do to stay in compliance, so we can go ahead and work around your security strategy there. Alerting through CryptoAuditor is done in one of two ways. We can either integrate through a syslog server or an email address. As you can see here, there's several different ways that we can alert, whether that's system alerts for low disk storage, people logging in, etc., or your audited connection alerts. So if somebody tried to log in with an invalid credential, would be an example of that. Your external authentication is going to be your LDAP server, your Radius servers. And one of the things to point out here is by doing a bind through a Radius integration, we can actually enable multi-factor authentication through vendors like RSA, Ping, Duo, without actually having to cause the customer to go out and change their environment in any way. So they don't have to go out and do the configuration file change or the PAM change or install an agent on any of their endpoints. We can just integrate it straight from CryptoAuditor, and it's more like a light switch. Once the product is integrated, we can turn it on in the rule, and then multi-factor authentication will be enabled to their environment or subsets of their environment, depending on how they wanted to roll that out. Your external services here is going to be your email bind, your SIM solution, and we do support syslog, Leaf, and CEF. I think that pretty much covers any SIM solution that's out there. Your content inspections is going to be your IDS or your DLP. I'm using bits for this example. It's a standard bind over 1344, and we already have all the headers built in here. And then the last thing that we really didn't talk about was the main components of CryptoAuditor. So there are two. There's the Vault, which is the central policy management engine, and then there's the Hounds. And the Hounds can be deployed out through your network infrastructure in three different ways. They can be deployed out as a bastion, which would be primarily like a jump server type proxy solution, a router, which would be a layer 3 deployment. They can work in conjunction with advanced firewalls through application or port-based routing policies, for example, or bridge mode, which is a layer 2 deployment where we can leverage VLAN tagging and things like that. You can have a combination of these deployed out through the environment. Hounds can be deployed strategically, so into or out of, say, a PCI environment, or in front of any externally facing SFTP server, as just a couple quick examples. And all three of these can be deployed transparently to the user community with no need to install any sort of agents or change any existing tools. The last thing that I wanted to highlight in this quick product overview is troubleshooting CryptoAuditor. We made it very, very easy. So through the web UI here, we can actually come in and look at troubleshooting the system through a simple drop down. We built in a lot of scripts to go out and grab you the log files and do any sort of diagnostics. So we, through this drop down menu here, if I'm having trouble with the Vault, for example, or any one of my deployed or distributed Hounds, I can just simply select it from this drop down menu and click Run Troubleshoot. It'll go grab all the pertinent information, package it up nicely in an easily to read format. Thank you.